Hello and welcome. Today we're going to look at section 8.5, which is the remainder and factor theorems. So we're going to continue on using the synthetic division that we've been using for the last day. And we're going to talk about how we can apply this to a couple of different areas. So our first step is we're going to follow through a couple of these problems and we're going to look at what relationship seems to exist. And then we'll look at why that works. So we're going to do synthetic division just like we did yesterday. So this, right, we're at x minus c. So right, we have our 3 for our index out there. And we have 2, -7, 6, and -3 are our coefficients. So we just follow through with our normal synthetic division. So 2, 3 times 2 is 6. -7 and 6 is -1. -1 times 3 is -3. 6 and -3 is 3. 3 times 3 gives me 9, and a -3 and 9 gives me a positive 6. So remember, we start off with x cubed, so this is our x squared term, our x term, our constant, and our remainder. So when we go to write that out, that's 2x squared minus x plus 3, and then plus 6 over our original divisor, which was x minus 3. Now if I take this same function that I was using and I put 3 in for x, 2 times 3 cubed minus 7 times 3 squared plus 6 times 3 minus 3. So 3 cubed is 27, so 2 times 27 minus 7 times 3 squared would be 9, plus 6 times 3 is 18, minus 3. 2 times 27 is 54. 7 times 9 is 63. So 54 minus 63 plus 18 minus 3 gives us 6. Well, that's interesting. 6 is our remainder. 6. Okay. So let's try another one. Okay, so this time, right, x minus c, so we have -2 because we have the plus, and so remember, it'd have to be minus a negative to get the plus. And then we have 1, 6, 5, -10 are those coefficients we need to bring down. Bring our 1 down, times a -2 is -2, 6 and -2 is 4. 4 times a -2 is a -8. 5 plus a -8 is -3. -2 times -3 gives me a positive 6. -10 and positive 6 gives us a -4. So again, we start off with the third power, so it's our x squared, our x, our constant, and our remainder. So this is going to be x squared plus 4x minus 3, then plus a -4 over x plus 2. We take that -2 that we used over here and we put it in for x. Let's see what happens. A -2 cubed plus 6 times a -2 squared plus 5 times a -2 minus 10. -2 cubed is a -8. -2 squared is a positive 4, so 6 times 4. 5 times a -2 is a -10, and then minus 10. So that's -8 plus 24 minus 10 minus 10 gives us -4. So we have -4 for our remainder. We have -4 for our answer when we put in that value. So that means if we put in, right, our C value into our initial problem, that's going to give us our remainder. That's pretty darn cool. So then that begs the question, will that always work? Well, in fact, it will always work. Okay? And why does it always work? Well, we can use the division algorithm and show step by step why, right? When we have our x minus c, right, and we put c in for x, you end up with c minus c, which just gives us 0. And 0 times anything always just gives us 0. So when we put in a value of c, we're always just going to get our remainder. Okay, so now it says use synthetic division to find the value. So again, we're going to just put this value in to figure out what that would be. So, right, -5 is what we're entering in. So that's going to be our index. Okay, and then our coefficients are going to be 1, 2, -1, and 4. Bring down our 1. -5 times 1 is -5. 2 and -5 is -3. -5 and -3 is a positive 15. -1 and a positive 15 is a positive 14. Times a -5 is a -70. 4 and a -70 gives us a -66. So again, right, we start with the third degree, so it's our x squared, our x, our constant, and our remainder. So this, right, what we're looking for is that remainder, because we know that remainder has to equal, right, the same value. So that is our actual answer, right, -66. Okay, you can always double check that and make sure that that'll work by putting -5 in up here, right? -5 cubed plus 2 times a -5 squared minus, -5. Oh, got to put in the minus a negative, so that's really going to be +5, and then +4. So -5 cubed is a -125. -5 squared is 25. Plus 5 plus 4, so -125 plus 50 plus 5 plus 4 also gives us that -66. So yet again, just one more example of how it works. Now we can use that to our advantage, right? Because there are a few things we know, right? When we factor things out, right? If we have a remainder of 0, that means it factors out perfectly, right? We end up with those factors that we can then multiply back together to start, right, to go right back to where we started. So anytime we want to know if something is a factor, we can put in and use, or put that back in using the synthetic division to determine if there's a remainder or not. So if we do that, so we're going to use our index would be 2, and then we can just use our coefficients, 1, -4, 5, 4, and -12. Bring down our 1. 2 times 1 is 2. -4 plus 2 is -2. Times 2 would be -4. 5 and -4 is a positive 1. 2 times 1 is 2. 4 plus 2 is 6. 2 times 6 is 12. We get that remainder of 0, right? That's what we're looking for. That means it does factor out completely, which means, yes, it is a factor. So our final answer on that would actually be yes. Okay, let's look at another one of those. Okay, is x minus 1 a factor? Well, that does not look like a whole lot of fun to factor. So we're going to use that fact that we just learned, right, that if we want to know if the remainder is 0 or not, we can just simply put that value in, and if we get 0 for an answer, that means that it will factor out. So I'm going to take, right, my c value here would just be 1, or my index value. So I'm going to put into my function, okay, 1. So that would be 2 times 1 to the 173rd plus 1 to the 47th plus 1 to the 13th. Well, that really is just 2 times 1, because 1 to any power is just 1, plus 1 plus 1. So that gives us 4. So that means our remainder is 4. Well, if our remainder is 4, right, that is our remainder. Does it work? Well, no, right? 4 does not equal 0, and the remainder has to be 0 for it to divide out evenly. So the answer is no. All right, now we also know, okay, that when we have polynomial, right, when we have zeros or roots of polynomial equations, we know how we can write those out, right? So if our roots are at 1, a -3/2, and 2, but we want them to have these integral or integers, so that means, right, this would normally be like x minus 1, okay, for 2 it would be x minus 2, and then for this one, right, this would be like x plus 3/2, but we need this to be an integer. So we're going to multiply everything in here, Okay, so that way we can get rid of that. So if we just multiply this whole thing by 2, right, that would be 2x plus 3 now. So we're not going to use that one, we're going to use 2x plus 3. So now we know if we multiply those together, it will give us back our original equation. So that would be x minus 1 times x minus 2. So that's x squared, and then it's going to be minus 2x minus x plus 2. All right, and then that quantity is times 2x plus 3. So that's really x squared minus 3x plus 2 times 2x plus 3. And then when we multiply that, right, each thing in here by each thing over there, it's going to give us 2x cubed plus 3x squared, and then minus 6x squared minus 9x plus 4x plus 6. Okay, so then we just combine like terms. 2x cubed, we have 3x squared negative 6, so I'll leave you with a negative 3x squared. So the negative 3 times negative 3x squared, and then we would have negative 9x, positive 4x would leave us with a positive, or sorry, negative, okay, 5x, and then plus 6. Okay, now on number 5, okay, they're going to give us this big long thing, and then they're going to tell us this is one root. They want us to find the other roots. So since we know this is a root, we know that that will work, right, as a c value. So if we put that in for our index value here, right, we have our 1/3 for our index, and then we do 3, negative 1, negative 18, and 6 for our coefficients. We bring down our 3. 1/3 times 3 is just 1. Negative 1 and 1 is 0. 1/3 times 0 is 0. Negative 18 and 0 is negative 18. So 1/3 times negative 18 is negative 6. 6 and negative 6 gives me 0. So that means, right, this remainder is 0, which is what should have happened, right, because we got that this was one of our zeros. So now, right, we have this, which this is our squared term, right? That would be our x term, our constant, our remainder. So we now know, right, that 3x squared minus 18 has to equal 0. So we can solve this, right? We can add 18 to both sides. We get 3x squared equals 18. We divide both sides by 3, and we get x squared equals 6. We can then take the square root of both sides, and we get x equals plus or minus the square root of 6. So that means we have 3 different answers, right? Our first answer for x was 1/3 that they gave us. Our second answer for x is the negative square root of 6. And the third answer that they gave us was the positive square root of 6. So those are the 3 possible answers, right? Those are all of our roots. So hopefully that was helpful. Your homework is on page 375 and 376. Good luck.